Alright, hi everyone. First things first, just a little preview of your quiz. Some of you were asking for. Trying to get this up here as soon as possible. Tangent of x plus cotangent of x equals secant of x times cosecant of x. All I want to do here is, does this appear to be an identity? I'm not going to prove it, just going to ask, does it appear to be an identity? And when we have that, what we will do is put this in the calculator. Let me just start over here. Now, I am going to leave the second one on here. As you see, it's the circle. Now, if you just press on this over here, you can change. I got a circle without the graph. I got a dotted line here. I got a regular line here. I got a heavy line here. I got a shaded part, and I'm going to leave it on the circle. So that's the second one. I'll leave the first one as just a regular graph. Now I'm going to graph y equals tangent of x plus cotangent, which is the reciprocal of the tangent. So I'm just going to write 1 divided by tangent of x. Let's go ahead and graph that. Oh, I had hit zoom trig before I started this. Gives us a nice look at a trig function here. And that is the left side, the right side, secant of x times cosecant of x. So I'm going to hit the y equals. I'm going to go down here. The secant of x is secant. That is 1 over cosine, right? Right. 1 divided by cosine x. And I'll close parentheses there, times, and then cosecant. That's 1 divided by sine of x, or the reciprocal of sine of x. 1 divided by sine x. Close that. And let's look at the graph. And notice how nice that circle follows the curves there of the original. Which leads me to say that yes, this does appear to be an identity. I'm not going to solve the identity, I'm just going to say yes, it does appear to be an identity. Now, let's look at just, if this is not an identity, let's come up with a counterexample for it. Tangent of x plus pi over 2 plus equals tan of negative x, tangent of negative x. Well, let's test it. Hit the y equals button here. Equals tan of x plus pi over 2. Let me delete everything here. Okay. And let's clear that equation, and let's do tan of negative x. All right. Here's the first function. Nope. Ain't working. Well, let's look at a place where it doesn't work. I'm going to trace this right there. Don't do it there because that's where they're intersecting. When You can do anything here. Let me do this. Right there. When x equals 2.09, the tan of x plus pi over 2 on this side is about 0.577. I hit the down arrow, it jumps up to this one. The tan of negative x at the same value of x is 1.732. Okay, these are not equal for the same value of x, so that is a counterexample. Say let x equal this, then x plus tangent of x plus pi over 2 equals 0.577, and the tangent of negative 2.094 is 1.732. There's a counterexample. Just find a place where they're not equal. You can do other ones if you want. All right. Next, find an identity for the cosine of x plus 2 pi over 3. Well, something that's equal to it. I know that the cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha times, I'll just write down here, sine beta. So let's deal with that a little bit. And okay, I was just double checking to make sure I had the right identity. That'd be cosine x times cosine of 2 pi over 3 minus sine x times sine of 2 pi over 3. And if I think, I don't know why I wrote it that way. Okay, if I think of 2 pi over 3, I'm thinking right here. And that looks to me like the cosine of 2 pi over 3 is negative 1/2. Cosine x times negative 1/2 minus, and then sine of x times square root of 3 over 2. So if I'm asking for an identity here, I might be inclined to write negative 1/2 cosine x minus radical 3 over 2 sine x. Make sure you can see all that. That would be the identity I would write for what this is. Substituting when you can. Okay. Let's try this one. Prove that the cosine of x plus the tangent of x times sine of x equals secant of x. Alright, I'm going to work with this side a little bit. And keep one handy here just in case I need a spare. Cosine of x plus tangent sine of x. I'm going to change everything on this side to change everything on this side, sorry, to sines and cosines, which is just the tangent here. Alright, so I'm looking at cosine x plus sine x times sine x is sine squared x over cosine x. So what I want to do is I'm going to multiply this one by cosine x over cosine x so that I can have a common denominator. I think it'd be easier if we get everything into one. So I'm looking at cosine squared x over cosine x. Is it still showing up here? Plus sine squared x over cosine of x. And let's write it as 1 since I have a common denominator now. I'll write cosine squared x plus sine squared x over cosine of x. Now I need you to know that the cosine squared of x plus the sine squared of x is 1. So that's 1 over cosine x. And 1 over cosine x is defined as, the secant of x. Okay. Let's do one more. If x is greater than pi and less than 3 pi over 2, put a negative there, and the sine of x equals negative 2/3, find the exact value of the tangent of x. All right, very interesting problem. Let's get a view of it on the unit circle. We're in the third quadrant. This is pi, this is 3 pi over 2. And the sine of x is negative 2/3. So, I don't know. Somewhere around here, we have negative 2/3 as the y-coordinate. Remember, the unit circle is 1. And what I really am going to use now is that the sine squared plus cosine squared is equal to 1. And let me do that real quick. So the sine squared x plus cosine squared x is equal to 1. We know that the sine of x is negative 2/3. So negative 2/3 squared plus cosine squared x is equal to 1. And that is 4/9 plus cosine squared x equals 1. And if I subtract 4/9, I got cosine squared x equals 5/9. And the cosine of x, there are 2 square roots. It's the square root of 5/9, and remember it's in the third quadrant, which makes it negative. And that is, so I'm going to go negative square root of 5 over the square root of 9, which is negative square root of 5 over 3. So, let's show this where I solved. Square root of 5 over square root of 9. Remember it's negative because we're in the third quadrant. So I'm going to put negative radical 5 over 3. Remember that tangent is sine over cosine. So it's negative 2/3 over negative radical 5/3, which is, the thirds will cancel out, the negatives will cancel out. 2, not negative 2, 2 over radical 5. And if I multiply top and bottom by the square root of 5, the exact value is 2 radical 5 over 5. That's the exact value for tangent of x. Let me know if that needs more work. Thanks for now. We'll see ya.